Yes, dual nature of a radiation, that is dual nature of matter. Okay, yes, let us discuss about this chapter. Dual nature of light. First of all, we will discuss about the duality. What is actually the duality of a matter, that is a light? Duality means double. Okay, double role. How the role is possessed with the light, let us see. Okay, first of all, light exhibits a wave nature. So the wave and the particle nature. Let us discuss about how we can confirm light behaves as light shows wave nature. Light rays behave, light particles behave as a wave. Let us see. Okay, let us learn about the wave nature of light. Okay, light exists in the form of a wave. How? See, let us suppose that here the sun rays, whenever you are observing sunlight, here wave is defined as a mode of transfer of energy, right? Wave consists of alternate crest and trough, right? See, are you observing crest and trough here? Let me show the diagram here. Yeah, this is crest means the part of that, trough means this. Okay, crest, trough. Okay, characteristics. With what characteristics we can confirm the light is behaving as a wave? Okay, what are the characteristics? See, there are some characteristics explained only by the wave nature of light. That is, first of all, a reflection. I want to say the reflection, the phenomenon of a light reflection, we can confirm it behaves as a wave. See, what is reflection? It is the phenomenon in which the incident wave is bounced back from the surface of an opaque medium. Okay? Yes, like this. See, whenever you consider a plain mirror, then the incident ray is getting bounced back. Okay? With some angle of incidence, it is possessing some angle of reflection. Okay? And the second phenomena, refraction. The refraction is nothing but the bending of light ray when light ray moves from one medium to another medium. Okay, see, let's suppose that with some angle of incidence, the ray is propagating from one medium to other medium. Are you observing this phenomenon? So this is possible. The reflection, the phenomenon of a reflection is possible only because of wave nature. Okay, yeah, like this reflection we can observe like this in a water. Sorry, refraction, sorry. Okay, now come to interference of light, the phenomenon in which the superposition of two waves or more light waves produce a resultant light intensity or energy, that is called interference of light. See, this is the phenomenon of interference of light, where this is actually the screen with a slit. Here, two slits. The light, the monochromatic ray is allowed to pass through these two slits. Then, whenever you are observing, this is a source for this wavefront, where this is the mid of this wavefront. These, due to this, what happens at point of here, at point of contact, these two actually, at this point we are observing here. See, at this point we are observing all these points, observe all these points. Okay, this is actually whenever you are observing an optical screen, you can the wavefront, you can observe light and a dark rays like this, light path, dark, light, dark. This is the phenomenon of interference. Okay, now come to diffraction. The diffraction of light means the bending of light waves at an edge into the region of the geometrical shadow, which is called diffraction of light. Okay, so this is the some wavefronts. Whenever, let us suppose the diffraction you can observe in a simple manner. For a street light, if you insert a cloth, if you insert a cloth in between your vision and the street light, you can observe some small dots. The light can appear as a small dots. That is due to phenomenon of diffraction. Why? Because the light is bending at the edge of the region. Okay, so that is actually the diffraction. So what I want to say is that all these phenomenon of a all these phenomenon of a reflection, refraction, interference, diffraction means this process of light is exhibited by only the wave nature. So light is behaving as a wave is one of the concepts. Okay, light is behaving as a wave. Now come to some phenomenon, we can observe light is behaving as a particle. Where it is behaving like a particle, come, we will observe. See, particle, let us learn about the particle nature of light. See, this the sunlight, whenever we are observing, sunlight is exhibiting in terms of photons. The yellow color blocks are the photons. Light is said to be behave like a particles. Just now in previous slides we discussed that light is behaving as a wave. Proof also we observed using the phenomenon of interference, diffraction, refraction, reflection. Okay. Now see here we are observing light is said to be like a particles also. This is actually the duality. Light is behaving as a particle as well as wave. Okay, that duality we are discussing. Due to that duality, what is going on with particle nature, what we can observe, with wave nature, what we can observe, if combined together the particle nature and wave nature, which is so called duality, what we can observe, we will discuss in this chapter. Okay. Yes, light is said to be like a particle, behave like a particles. In this nature, light behaves as like a small discrete set of packets of energy, which you have studied in earlier class. Those are called actually the photons. Okay, so according to scientist Max Planck, light is used to behave like a discrete set of packets, which we can say the quanta of energy. Okay, the quanta of energy, that quantas are said to be photons. Okay, so the dual nature of a light, actually, see, he named those particle packets of energy as a quanta. Okay, Max Planck, according to Max Planck theory, quanta means one single packet only, like that. I made it, no? So that is single packet is known as photon. Okay, the photons are defined as photons, better not protons. Photons are defined as packets of energy. Okay, one of the main characteristics explained by the particle nature of light, how we can observe, how we can say the light is behaving like a particle, means one of the experiments we can say that photoelectric effect. Okay, so what is photoelectric effect? We will discuss. Okay. Yeah, that is Max Planck quantum theory. Just we will focus for 2 seconds. Planck quantum theory. In this theory, actually, this theory was in 1900. Um, in the year of 1900, the Max Planck gave a theory regarding the quantas. It tells us that the light is propagated through free space in the form of discrete packets or bundles, what we can say. Okay, quanta. Yeah, these bundles or packets are called as quanta or photons. See, this is the, let us suppose that the sunlight which is exhibiting in the form of quantas. Quanta means here what? The packets of energy. See, these are the packets. Let us suppose that I have drawn like a candies, no, here cubes. These are the packets of energy. So these are known as quanta or photons. Okay, if the frequency of each incident radiation is mu, that is the energy of has each photon has some special energy. Okay, that energy can be displayed, that is discussed as E is equal to h nu, that can be derived as E is equal to h nu, where h is the Planck's constant, which is the value, the constant, which is about 6.634 into 10 power minus 34 joules per. Yes, these photons travel with the speed of light, that is 3 into 10 power 8 meters per second. Okay. Properties of photons. What may be the properties of photons here? That is, each photon has energy which is equal to h nu. That is E equal to h nu. The speed of light. All the photons possess with the uh, speed which is equal to speed of light. That is E is equal to nu lambda. Hence, the equation for energy becomes, if I substitute here, what will happen? Equation for energy is equal to, in case of here nu, I will substitute c by lambda. That is E is equal to hc by lambda, right? Yeah. So E is equal to hc by lambda, where nu is the frequency of incident radiation, where lambda means wavelength of incident radiation. Okay. Energy is independent of intensity. Remember, here the energy of a photon is independent of intensity. Yeah. Come to properties of photons. Again, still we are continuing. Photons are electrically neutral. Don't say photons means positive charge, negative charge, not like that. Photon are Photons are electrically neutral and are not deflected by any either electrical or magnetic field. Either electric or magnetic field, they does not deflect. Okay, the photon doesn't deflect to the electric or the magnetic field. Let us suppose that I am drawing electric field here. This is electric field. I want to draw the magnetic field. NS means north south, the magnetic field. So whenever the photons are allowed to pass here, yeah, see, all are they deviating anywhere? Those are just traveling about their path. That's it, not deflecting at all. Okay, this is about the property. And next, photons have a definite amount of energy and linear momentum. The number of photons may not be conserved in a collision. Remember, okay, the number of photons may not be conserved in a collision, where due to the collision the photons may lose or photons may gain, okay, by the whatever the source. Okay. Yeah, this is actually the properties of photons. Okay, is it clear? Now, the first actually the photoelectric effect, what we are saying, that photoelectric effect was first observed by the scientist Hedge. Okay, the photoelectric effect, first the small observation done by Hedge, the scientist. What he has observed, let me discuss. Okay, that is Heinrich Rudolf Hedge in the year 1857 to 94 actually is the time. Actually, he discussed, the German physicist, he discussed about the photoelectric, the concept of photoelectric effect. Okay, during his experiment on electromagnetic waves, yeah, he observed that a spark gap conducts electricity more easily when illuminated by UV light. The spark means, where is the spark? What is the spark? I have given diagram where you don't have in textbook beta. Just make a screenshot here. Okay. Yeah. So in the textbook only some theory was given, but not this diagram. So what is actually this diagram replicating is that whenever you are using frequency oscillators and some induction coil in between, the spark gap he has observed due to photons. Actually before this experiment, they used to illuminate using UV light. So after that, what they have observed means, whenever they have arranged in such a way that the spark gap more than that illumination, the spark whatever it is coming from the metallic surface, it is more energetic. So the spark gap is actually the due to photoelectric effect. Sorry. Yes. So what is the spark and what actually causes for the spark? Let us discuss. Okay, that is electric spark were generated in the gap, that is electrons. Spark means what? The electrons are generating. The meaning is that electrons are generating. So when electrons were generated, the electron which were generated were used to be known as negatively charged particles. Now actually they are electrons, we are saying. This discovery was called a Hedge effect. We can say actually Hedge effect. Previously we were used to say Hedge effect, and now it is known as photoelectric effect. So what is photoelectric effect? In detail we will discuss. Okay. So these German physicists, these two actually Hall was Leonard, actually Leonard potentials, William Hall watches, all these people also studied about this photoelectric effect and delivered some facts regarding photoelectric effect. What are the facts? Facts means here electron emission occurs only with radiations below a critical wavelength, that is about a critical frequency. Okay, whenever the critical frequency is allowed to fall on some metallic surface, then only we can observe the that is the phenomenon of a photoelectric effect. The kinetic energy of the emitted electrons increases as the wavelength decreases. Okay, or we can say in other form, frequency increases, but it is independent of incident radiation. Okay, and alkali, some alkali metals they have observed with some alkali metals are suitable for this photoelectric effect, to observe the photoelectric effect. So what are those alkali metals? Yes, what are those alkali metals and why? See, why? Because actually the because of alkali metals like cesium, potassium, and sodium. See here, these are the materials emit photoelectrons even when visible light is incident upon it. So that is the reason whenever visible light is allowed to fall on those materials like cesium, potassium, sodium. Cesium is about atomic number is about do you remember 55 around, I think. Yeah, 55. Like this, all these materials, potassium 13, sodium 11, like these atomic numbered materials emit photoelectrons even when visible light is incident upon it. That is the reason. So these are highly reactive materials. So these are suitable to observe the photoelectric effect. Okay. Yeah. Now photoelectric effect. So what is photoelectric effect? We will study what the definition. Let me discuss the definition. The process of emission of electrons from metal surface when the light of a suitable frequency fall on that metal. Is it clear? The process of emission of electrons from metal surface when light of a suitable frequency falls on the metal. How? If a suitable frequency falls on the metal, how the emission, how the electrons emitted? Still confusion, no? Surface, actually metal surface is called photoelectric effect. See, when this is, let us suppose that here this is the what the metal surface, the negative charges are there, no? Those are the electrons in a negative metal, means it consists of, yeah, electrons around the free electrons. Outermost shell, it consists of free electrons. It is supposed with the free electrons in the outermost shell. So when this is the light, this is a suitable frequency. This is okay. When suitable frequency is allowed to fall on these metallic surface, then what happens? These electrons are emitting out. Okay, by grasping these photons, these electrons get excited and these are emitting out with by grasping external energy. That is actually, this phenomenon is known as photoelectric effect. Okay, this is incident radiation where these are the photoelectrons, where this is the alkali metal surface. Okay, still confused? Yeah, let me explain very clearly here. Let us study photoelectric effect in detail. Consider a metal surface. Just take a metal surface. This is a metal surface. Is it clear? Yeah, in this metal surface, it has a lot of free electrons. I will draw electrons. Yeah, these are the electrons. Okay, it consists of lot of free electrons. Of course, any metal surface has a lot of free electrons, no? Yeah. Now, these electrons are in random motion like this. These electrons are, always those are in random motion about its position. Okay, see, random moment. Yes, these electrons have tendency to get excited. Random motion is there, no? These electrons have tendency to get excited when they receive certain amount of energy. Yes, like you people. Okay, you people have tendency to cross your intermediate, no? By grasping energy, by grasping some external talent from the textbook and the teacher, the you people are tendency to cross the level. So same likewise electrons also tendency to get excited from that position which they are existing on a surface. Then so that the characteristic of electron will be studied in this module. See, let me explain. Now according to Planck's quantum theory, the incident energy is in a discrete form, that is in the packets and not in a continuous form. Okay, incident energy is always it is in a exhibit in a packets. Okay, so each photon coming from the same source has the same amount of energy, right? Whatever the photon is coming from a source has the same amount of energy, which is actually is equal to h nu. This is actually fact from Max Planck theory. Okay, now I am giving source to this. In a metal surface, there are lots of free electrons, but these electrons cannot come out of the metal surface as it is requires a certain amount of energy. Okay, these electrons, whatever the electrons are there, those are tendency to come out, but those are not come for free, no? Yes. So what happens? The minimum amount of energy is required for the emission of photoelectrons from the metal. That is the minimum amount of energy, whatever it is required, that is known as work function. So we have to do some work function. We have to give for some work function to the metal. Then those electrons will be get out from the metal. Are you following? This minimum amount of energy is known as work function. Are you with me, beta? Are you following? So, whenever the metallic surface is there, is any phenomenon is coming to your mind? Yes, solar cells, solar plates are the same photoelectric effect only. Concentrate. Okay, if you understand this, you can understand that application. This is the same photoelectric effect we are using the solar power to energize the plate. Whenever the sunlight is allowed to fall on the solar plate, then what happens? Electrons are emitting out. Those electrons we are collecting. That is nothing but current, solar power. Is it okay? Yeah. So in order to obtain the electrons to get out from the metallic surface, what we can do? The minimum amount of energy we have to give. Okay, we have to supply the minimum amount of energy, whatever we are supplying, that is known as work function. Okay. Yeah. So work function means, see, different metal surfaces have different work function. Don't think that all metal have same work function. Some students can understand for the first time only. Some students can understand the last time. Some student can understand when I repeat for twice, like that. Okay. Different material have different work function, beta. Okay, so when light is incident on the metal surface, it should have a certain amount of energy, which that energy should be more than or equal to the work function, right? Right? Yes. You have to note the points. Don't listen like a story. Okay. Consider a light energy which is incident on the metal plate. Yeah, now I'm taking the light. that is a our natural big star is, yeah, sunlight is allowed to fall on the metal surface. I am giving sunlight. When light energy is incident on a metal surface, the electron absorbs the energy, and if light has the same energy as that of work function, let us suppose that I am giving work function to the metal, okay, that is the work function h mu naught, that is h mu is equal to h nu is no that energy of this, so energy of photon, so energy of photon is h nu, so which is equal to work function W naught. Then there will be emission of electrons is possible, where V naught actually we can say threshold frequency. Okay, V naught we can say here it is a threshold frequency. Threshold means behold frequency which has electron in a metal to be hold in a metal. That threshold frequency whenever you are equal to that, we are supplying work function. Yeah, see, the sunlight is allowed to fall on the metal surface. Then what happens? From the sunlight, what will come? Photons will come, right? Yeah, see, photons are coming. These are the photons, packets of energy. In previous slide, I drawn now. So, packet of energy is allowed to fall on the metallic surface. This is the phenomenon I am showing, photoelectric effect. Okay, now. So, this is actually the electron. The sunlight is allowed to fall on metallic surface. So, sunlight is falling means the photons are allowed to fall on metal surface. Then what happens? Whatever E is equal to h nu, photons means energy of a photon is E is equal to h nu. That is h nu of energy is grasped by these electrons. Some of the electrons. When the energy grasped by the electrons, immediately those should not be reside with the metal. Those wants to be come out. So then what happens? The electrons are getting out. Okay, so when these electrons are getting electron is nothing but what? The movement of electron is nothing but current, no? So electrons are getting out. These we are collecting. These electrons are said to be photoelectrons. Okay, these electrons are said to be photoelectrons. The entire phenomenon is said to be photoelectric effect. Okay. Now, H nu. Actually, what we have a work function we have supplied to that material, that is H mu naught, which is equal to the W naught. The photo emission, when therefore photo emission that is takes place there. Okay, when incident light source has H mu naught greater than W naught, that is a work function, then also the free electrons absorb all the energy incident on it, and the emission of electrons takes place, and these electron possess kinetic energy. Those are moving means those are possessing kinetic energy. Are you following? Yes. Yes, see, whenever the light is allowed to fall on this is taking place, no, this phenomenon is taking place, electrons are getting out, so that what we can observe, h nu naught is greater than w naught. That is equal also, more than that also. Two cases are there. Whenever w naught work function is equal to energy of a photon h nu naught, then also photo emission is possible. And the second case, when h nu naught is greater than w naught also takes place, then photo emission will takes place and electron will possess kinetic energy. Whenever it is equal, it grasp the energy. Whenever more than that, then it is, yeah, possessed with some kinetic energy. Yes, this is the kinetic energy. When incident light has h nu naught which is less than work function, let us suppose that less than work function, what happens? Then the electron will not absorb this energy beta. Okay, the electron will not absorb this energy, but as it is being so less, it will be insufficient for the electron to eject out from the metallic surface. Okay. Okay, then we cannot observe emission from the metal surface. Okay, see, like this. Here it is H nu I am supplying, but electrons are not coming out. Why? Because here work function is less than that of H nu. Okay. Yeah. So first condition for the emission of electron from the metal surface. What is the condition for the photoelectric effect? Remember, the first condition should be the light which is incident upon this should be H nu naught should be greater than that omega naught. Okay. Yeah. So H nu naught is less than omega naught, then photo emission will not takes place. Bit point of view, very very important. The condition for photoelectric effect, he will ask like that. Okay, now E is equal to H nu. So E proportional to nu. This is only no E proportional to mu, where H is the constant, no? So emission will not takes place. Okay, whenever, so when incident light has mu, that is mu is greater than threshold here. V naught is the threshold frequency. So mu greater than or equal to the photo emission takes place. So when the photo emission takes place, when the photo emission doesn't takes place, I have given in two, yes, two way different concept here, two different shapes I have given. Yeah, the minimum frequency of incident radiation at which photoelectrons are ejected from alkali metals is known as threshold frequency. Threshold frequency definition I am giving here. Now, the second condition is nu greater than or equal to nu naught. This is actually we have discussed just now for a photo emission. I am keep on repeating. Now I will repeat three. What are the sufficient equations? I will make in a single slide. Where mu is equal to c by lambda, where we know already this. When lambda increases, v decreases, and if nu becomes less than mu naught, the photo emission will not takes place. The third condition is that lambda less than or equal to lambda naught. Then only photo emission takes place. Why? Because if nu and lambda reverse relation is there, nu is equal to c by lambda, no? So mu should be greater than equal to mu naught. Lambda should be less than or equal to lambda naught. Is it clear? Dear students, is it clear? Yes, now the three conditions I am making in a single slide. For the photoelectric effect, there should be necessary conditions are three. The first condition is that H nu is greater than or equal to W naught, that is the work function. Okay, first condition is H nu is greater than or equal to W naught. Second is that mu is greater than or equal to mu naught, where the third condition is lambda is less than or equal to lambda naught. These are the three conditions for photoelectric effect. Is it clear? Yes. So now definition for the work function. Work function definition means it is defined as minimum amount of energy of a photon required, which must be incident on photosensitive materials to liberate a photoelectron from its surface. Liberate means generate, to getting out. Okay, so work function means simply saying the work, the amount of energy required to get an electron from the metallic surface. That's it. Okay. Yeah. Photoelectrons. What are photoelectrons? The terms, these two terms we have used till now. Photoelectrons means the electrons emitted from surface of a metal when a light of a suitable energy above a certain value falls on the surface is called photoelectrons. Means the electrons which are, simply saying, the electrons which are emitting out, the electrons which are emitting out as soon as the photo whatever radiation is supplied to the metal, whatever the electrons are coming out, that electrons are said to be photoelectrons, because that electrons have emitted out due to the photons. So photoelectrons. Now come to the point, threshold frequency. What is threshold? It is a minimum frequency of incident light required for the emission of photoelectrons from the alkali metal surface. That is actually threshold. Okay, threshold frequency. Threshold wavelength means it is a minimum wavelength of incidental light required for the emission of photoelectrons from alkali metal surface. This is about threshold wavelength, threshold frequency, photoelectrons. Okay, these are the definitions whatever we have used till now in a photoelectric effect. Is it clear? In today's class we have studied about photoelectric effect, that is a work function, photoelectrons, threshold frequency, threshold wavelength. Okay, threshold frequency should be greater than, that is v, that is the frequency of that is equal to greater than or equal to threshold frequency. Wavelength of the photons should be equal to less than that threshold wavelength. This is the these three are the conditions for, what is the third condition? H nu is greater than or equal to work function. These three are the necessity condition to observe the photoelectric effect. Yes, now come to experimental study of photoelectric effect. Okay, construction and working with the diagram, how they have observed the Hedge and remaining scientists, how they have observed. The concluded experiment is that the construction follows the Hedge experiment. Let me shown first. The Hedge experiment arrangement for the photoelectric effect, which consists of some evacuated glass tube which has a quartz window. Okay, what is a quartz? Quartz is a material, beta. Okay. Oh, I have given this also. Quartz is a material which actually it is a silicate material mineral which is found under the earth continental crust. Okay. Hmm. Why do we prefer quartz window here? Yeah, this is the tube which consists of quartz window. The why we prefer means it is made up of quartz because allowed only UV rays to enter into the tube. The photosensitive material, that is actually quartz is the material of photosensitive material. Okay, that is the reason we are using here. The Hedge has used the quartz window here. Okay, in order to allow only specific light, specific wavelength, specific frequency of photons. Okay, this glass tube consists of a photosensitive plate E, known as a cathode, or we can say emitter, and a metal plate known as anode, which is also collector. So with one emitter and one collector, we that is glass tube is as arranged to grasp the photons. See, electrode, this is collector, like that. Okay, yeah. At this instant the photosensitive plate E has negative charge and the metal plate C has positive charge. Let us suppose that. Yeah, it consists of a reversing key known as a commutator. In our lab, we have that commutator, okay, which is used to maintain the collector plate desired positive and negative potential in desired direction. We can use that is actually the commutator. Okay, like this. Commutator means, see, this is the commutator dotted one. Okay, we can connect in this way or we can connect in this way, like that. Okay, yeah. It consists of voltmeter, which is used to measure the potential difference, and a micrometer to measure the photoelectric current. How much the current is required, how much current is generating in this, we can calculate. We can measure using the instruments. See, this is actually the construction. Is it clear? So it consists of a glass tube with the quartz window. Why we are using quartz crystal there means it is photosensitive material, and we are using sensitive plates of emitter and collector. Two electrodes we are using here. One is for one electrode for emission and one for the collector. Okay, and in order to pass the what current in different direction, we are using commutator, and to measure the same we are using voltmeter. To measure the current, we can use microammeter. It consists of a rheostat which is used to vary the potential difference of a plates. Okay, using this rheostat material, we can um, measure the potential difference between those two plates. Whatever we have used sensitive plates in, no, in glass tube, we can find out. Yeah, it consists of a battery which is used to apply potential difference to the plates. Now battery connection, end of this is the end connection. Okay, so we are supplying battery. This is the entire connection. Is it clear? Instead of giving diagram one after the other, I am giving, yeah, to make you understand. This is the construction and working. In the working point of view, what's going on? Let us see. Yeah, battery. From this battery, what is happening? See, consider a monochromatic source of light. The energy which is h nu greater than or equal to work function, as just we discussed, is incident on the battery quartz window, passing through which it is incident on photosensitive plate E. Okay, yes, the light is allowed to fall through this quartz window to electrode. That's it. When the light falls, what is the photosensitive plate will emit electrons which will be collected by the collector. Whenever electrons are emitting from that plate, then these electrons are collected by next end collector. So whenever electrons collected by the next end, what happens? We are able to measure, no? So by using this measurement, we can say that electrons, can we see with our naked eye? How can we say? How can we say means whenever this the light is allowed to fall on that, we can observe the deflection. We can observe the deflection in a voltmeter as well as in a meter, so that we can say that some process is going on. That the process is actually why it is increasing, why the deflection is taking place in the instruments, that is the measured instruments, means why the reflection? Due to emission of electrons. Okay, due to this, electric field will be generated and induced current is produced. Here like this I have shown the arrows, no? Yeah, the photoelectric current, the current which flows in some external closed circuit due to flow of electrons in that circuit is called photoelectric current. Okay, IP is the photoelectric current. That photoelectric current IP will be measured by the microammeter, and the potential difference is measured by the voltmeter. Okay, now we will study the variations in photoelectric current IP with respect to frequency of incident radiation, intensity of incident radiation, potential difference between those two plates. This we will discuss in the next class. Okay, till the time you just recollect what we have studied today. We just discussed about what is duality of matter, and we discussed that photoelectric effect. These sorry, the nature of photoelectric effect. What is the phenomenon of a photoelectric effect? So we have discussed all these terms in today's class. So what causes actually the photoelectric effect, we discussed. Okay, so in tomorrow class we will discuss about the photoelectric and what is the work function. There we can calculate the work function in the Hedge experiment. Okay.